Alright folks, here we go. Now we're doing a gravity problem, but using equation 4 and solving for v. If you don't remember, go ahead and pause the video when you see this here, and look at number 4, and we're going to be using that equation. So if we look at it real quick, final v squared is equal to vo squared plus 2a times the x, or delta x is what we call it, right? So if you look at this equation, I'm going to be solving for this. That means I'm going to have to know gravity. Well, this is a gravity problem. When you throw something, throw it up, it falls. A is always negative 9.8 meters per second squared. So we already know that. So we need to know this. I know how far it's going to move, and I know what speed it starts at. Luckily, we do know what speed it starts at, 0 meters per second, because it says a penny is dropped. So if something just falls or it's dropped, we know that initial velocity is 0. Right away, you know that. And also know that as long as we're on Earth, and we're assuming almost all the problems are on Earth unless they say otherwise, acceleration is negative 9.8 meters per second squared. Change of position. Remember, if something falls downward, you start at this position. Let's say that's position 0, right? Position 0. Then down here would be called negative 100. Up here would be called positive 100. So the change in position is negative 100 meters, okay? Since we're in this class, we're keeping everything down as negative and everything up as positive. We have to keep content. So if it moved downward 100 meters, I know the building is 100 meters tall, okay? I know that. But you're talking about the penny right here. Its starting position is here, and it changed its position downward when it fell. So from the time it started to the time it ended, start and finish, I should say, it moved downward. And somebody could say, well, isn't the building tall? It's positive, right? The building is. Yeah, it is, but the penny did not move upward. It changed its position from here to down below where it started, so it's in the negative position now. So here we go. That's everything we need. Let's plug it in. We don't know this one, and we do know that this is 0 squared plus 2 times negative 9.8, that's the acceleration, times the change in position, negative 100. And let's see here. Let's just do the quick math. Let's pull up a calculator and do the math real quick. We got the 0 at the beginning, so we don't need to worry about it. It's pretty much 2 times 9.8 times 100. And it's all positive because I'm going to have two negatives multiplied, correct? So 1960 is equal to v squared. But remember, v squared, I don't want to know what the velocity, the final speed when right before it hits the ground, is going this speed. And then if you square it, you get this number. I don't want to know that. I just want to know what v is. So let's square root that. And then it just becomes v is equal to, and let's get the square root. Square root of that number is 44.27. So let's say 44.3, I guess. And here we go. Check this out. Maybe you took this class before and they never explained this, but I'm going to explain this to you. Hey, right before this thing was hit the ground, it was moving what direction? Down. So its velocity is negative. So it's negative. And it's going negative. That's its final speed. And you might say, hey, but you did the calculation and you did the square root and it's 44. Well, the calculator doesn't show that, but this is an old rule from math that you should know. The teacher probably taught it and you probably thought, well, what does it matter? I don't need to know that. And let me explain it to you. When you first learned about square roots and you're a square root of 4, right? What does that mean? That means what number times itself will equal 4. What is the answer to that? The answer is it's either 2 or negative 2. Because 2 times itself is 4. So 2 squared is 4. Negative 2 squared is also 4. So the correct answer to this is equal to 2 or negative 2. And when you first learned that in math, you probably just said, well, that's dumb. I don't get it. Okay. But I'm just going to write the positive number every time, right? And that kind of worked. What does it really matter, right? Until in real life we start using that math. And then you start going, it does matter. We actually got the correct answer is 44 or negative 44. I already know what the correct answer is. It's negative 44 because it was heading downward. So I did not make that negative up. That's actually in the math, okay? And that's it, folks.